Hey everyone, welcome back to Quest 23, where we decode forensic science. Have you ever wondered how investigators catch criminals using just a single strand of hair, a tiny fiber, or even a speck of dust? Well, that's exactly what we are talking about today, trace evidence analysis. It's all about the microscopic clues that criminals unknowingly leave behind, and forensic experts use them to solve mysteries. Sounds cool, right? Well, trust me, by the end of this video, you will realize just how powerful even the smallest piece of evidence can be. So grab your detective hat, get comfortable, and let's jump right into it. So in this video, we will first start with an introduction. What is trace evidence? Why is it so important in criminal investigations? And how does something as small as a fiber or a speck of dust help forensic experts link a suspect to a crime scene? Then we will move on to the one of the most famous forensic principles, the Locard's exchange principle. After that, we will discuss the different types of evidences, like for example hair, fibers, gunshot residue, paint, glass, and etc. We'll discuss all of them. Next up, we'll dive into the collection and preservation of trace evidence. You can't just pick up a hair or a fiber with your bare hands. There are some specific rules and regulations that one must follow. Then comes the most exciting part, the analysis techniques. We will explore the fascinating science behind how forensic labs analyze trace evidence using microscopy, spectroscopy, chromatography, and many other advanced methods. And of course, forensic analysis comes with its own challenges. Contamination, sample degradation, legal admissibility, these issues can make or break a case. We will look at the hurdles forensic experts face and how they overcome them. And then finally, we will wrap up the video with a conclusion, summarizing why trace evidence plays a crucial role in modern crime solving and how forensic science continues to evolve. So if you are ready to step into the shoes of a forensic investigator and learn how even the tiniest clue can crack a case wide open, so stay tuned. First is the introduction. Alright, so before we go any deeper, let's start with the basics. What exactly is trace evidence? Well, imagine this. A crime just happened, and there's no obvious evidence, no weapons, no fingerprints, no CCTV footage, and anything else. But what if, hidden in plain sight, there's a tiny fiber on a chair, a single strand of hair on the floor, or even a small piece of glass stuck into the suspect's shoe? These tiny things might seem unimportant, but in forensic science, they can crack an entire case wide open. That's what trace evidence is. Tiny materials left behind that can link a suspect, a victim, or a crime scene together. It includes things like hair and fibers, glass fragments, paint chips, gunshot residue, soil and pollen, and many other things. These are only some of the most commonly found trace evidences in any crime scene, but there can be n number of trace evidences. And the process of identifying, collecting, and analyzing these microscopic materials in a forensic laboratory to establish connections between the victims, suspects, and crime scene is called trace evidence analysis. So even though they are tiny, they can tell a big story, and that's why trace evidence is so important in solving crimes. Criminals might wipe away the fingerprints or hidden weapons, but they almost always leave behind trace evidences, and forensic experts are trained to find them. Now that we know what trace evidence is, let's see why it's so crucial in forensic science. Think about it. Criminals always try to cover their tracks. They might clean a crime scene, wear gloves, or even burn evidences. But no matter how careful they are, they always leave behind something. And that something could be as small as a fiber from their clothes or a speck of dust from their shoes. So why is trace evidence so important? Let me break it down for you. First is that it connects people, places, and objects together. Forensic scientists can match a fiber from a crime scene to a suspect's clothing, proving that they were there at the crime scene. A tiny glass shard on a suspect's jacket could match the broken window of a burglary. These small connections can make a huge difference in solving a case. And then it can reconstruct what has happened in the crime scene. Imagine a hit and run case. A car speeds away and there's no witness. But investigators can find paint chips and broken glass at the scene. By analyzing this, they can identify the car's make, model, and even color. Now they have a lead. And one of the most important points is that it is hard to remove completely, meaning that trace evidence cannot be removed from the crime scene completely. Unlike fingerprints or DNA, which criminals might deliberately erase, trace evidence is often overlooked, and that is what makes it so powerful. A suspect might get rid of a weapon, but microscopic gunshot residues on their hand can still prove that they fired a gun. And then the last point is it supports other forensic evidence. Let us say a suspect claims they have never been inside the victim's car, but forensic experts find their hair and fibers inside. That directly contradicts their alibi. Trace evidence walks alongside DNA, fingerprints, and witness accounts to strengthen the case. So while these particles might be tiny, but their impact is huge. Now let's talk about one of the most famous principles in forensic science, that is the Locard's exchange principle. It was proposed by Dr. Edmund Locard, often called the Sherlock Holmes of Lyon, meaning the place in Paris. His principle is simple yet groundbreaking. It states that every contact leaves a trace. Now, what does this mean? Well, whenever two objects or people come in contact, they exchange materials, no matter how small. This could be fingerprints on a glass, hair on a sweater, soil on shoes, or even microscopic skin cells on a doorknob. Let's take an example. Imagine a suspect breaks into a house. He might leave behind footprints, fibers from his clothes, or even a single strand of hair. At the same time, he might take away something from the crime scene, like dust from the carpet, pet hair, or even glass fragments. Even if he tries to clean up, forensic scientists can still find these tiny traces, proving that he was there at the crime scene. This principle serves as the foundation of forensic science. It helps investigators connect suspects to the crime scene, victims to the perpetrators, and even uncover hidden evidence. So no matter how careful a criminal is, they always leave behind something, and that something is what helps forensic experts crack the case. Then let's dive into the different types of trace evidences that are commonly found in a crime scene. First, let's start with hair, one of the most common types of evidence found at crime scenes. Now, hair can provide vital clues in forensic investigations. It can help determine whether it came from a human or an animal. Also, it can give insights into the drugs used, diet, or even exposure to toxins, and sometimes even link a suspect to a crime scene. Now, a hair has three main parts: cuticle, cortex, and medulla. Cuticle is the outer layer which protects the hair, and cortex is the middle layer, containing pigments that gives hair its color, and lastly the medulla. Medulla is the innermost layer, which varies in structure between individuals. While hair can be a strong piece of circumstantial evidence, it cannot confirm identity unless DNA is present in the root. Still, a single strand can help build a case, making it a powerful clue in forensic science. Next up, we have fibers, tiny threads that can link a suspect, victim, or crime scene together. Fibers are often transferred during physical contacts, making them crucial in cases involving assaults, kidnappings, or even hit-and-run incidents. They can come from clothing, carpets, furniture, or even car interiors. Now there are two main parts of fibers: natural fibers and synthetic fibers. Now natural fibers are those that come from plants or animals, like cotton, wool, or silk. And then the synthetic fibers are the man-made fibers, such as polyester, nylon, or acrylic. Now what makes fiber evidence so valuable is that every fabric has a unique composition, and forensic scientists can compare samples to determine if they match. Even though fibers cannot pinpoint a person, they can strongly suggest contact between people or objects, making them a small but mighty clue in the forensic investigations. Then let's talk about glass fragments, one of the most overlooked yet powerful pieces of trace evidence. Imagine a hit-and-run accident or a break-in shattered glass, which can reveal where a suspect was, how a crime happened, or even the force of impact. Now, glass evidence can come in many forms, such as tempered glass, generally found in car windows, laminated glass, used in windshields, and window pane or bottle glass. What makes glass fascinating is that it breaks in a unique way, leaving behind fracture patterns that help reconstruct events. Plus, forensic experts can analyze refractive index, density, and chemical composition to match fragments to a specific source. Next up is paint chips. Think about cases involving hit-and-run accidents, burglaries, or vandalism. Paint evidence can link a suspect to the crime scene, or even identify the vehicle used. Now, paint comes in layers, and each layer, primer, base, coat, and a top coat, has a unique composition. Forensic experts examine color and texture to visually match samples. Forensic experts generally examine three things: the color and texture, layer structure, and chemical composition. For example, if a suspect's car scrapes against a victim's clothing, microscopic paint traces can transfer, making it possible to identify the make, model, and even the manufacturing year of the vehicle. And then the next type of evidence is gunshot residue. So when a gun is fired, it releases tiny particles of burnt and unburnt gunpowder. Metals like lead, barium, antimony are also released, and also even microscopic primer residues. These particles settle on the shooter's hand, clothing, and nearby surfaces within seconds. So why is GSR so important? Now it is important because it can help forensic experts determine if someone fired a gun or how close the shooter was to the target, and also it can determine if a suspect was near the scene of the shooting. So gunshot residue may be invisible to the naked eye, but in the hands of forensic scientists, it is a powerful clue that speaks volumes. Next up, we have soil, a surprisingly powerful forensic clue that can link a suspect to a crime scene. Now, you might be thinking, how can dirt solve crimes? Well, soil isn't just mud or dust. It is a unique mixture of minerals, organic matter, pollen, tiny rocks, and even microscopic organisms. No two locations have the same soil composition, which makes it an excellent piece of trace evidence. Now, forensic experts can use soil to connect a suspect to a location or reconstruct movements, also determine burial sites. For example, in a hit-and-run case, forensic scientists matched the soil on a car's tire to the crime scene, proving it had been there. Without that match, the suspect might have walked free. And then one of the most common type of trace evidence are fingerprints. Now fingerprints are like the nature's barcodes, unique to every individual, even identical twins. This makes them an invaluable tool in forensic investigations. But how do they end up as trace evidence? Well, every time we touch a surface, our fingers leave behind tiny residues of sweat, oils, and dirt. These impressions can be visible, like a greasy print on glass, or latent, that is invisible, requiring forensic techniques to reveal them. Now, fingerprints can help investigators by identifying suspects, track movements, and confirm identities. So, whether left on a door handle, weapon, or even a piece of tape, fingerprints are the silent storytellers of a crime. And the next type is bloodstains. Bloodstains are one of the most critical types of trace evidence in forensic investigations. They don't just confirm that a crime took place, also they tell a story. So when blood is found at a crime scene, forensic experts analyze its shape, size, and distribution to reconstruct what happened. This is called bloodstain pattern analysis. So why is bloodstain so important? So they are important because they can confirm violence. If there's blood, something serious likely occurred. Also, they can identify individuals from DNA matching. And lastly, they can reveal movement. The way blood is spread out can show that if someone has been moved or has been dragged or tried to escape. And finally, they can also indicate the weapon that is used. Different weapons create different patterns, like a gunshot spatter versus a blunt force impact stain. Alright, let's talk about saliva and sweat. Two things we all produce without even thinking. But in forensics, they can be a game changer. Now most people know about DNA in blood. But did you know that your saliva and sweat also contain DNA? That means, even without leaving behind blood or fingerprints, you can still be connected to a crime scene. Sounds crazy, right? So where do investigators find saliva? Well, think about this. Cigarette butts, soda cans, chewing gums, bite marks on a victim, even a simple spit on the ground can hold enough DNA to identify someone. And let's not forget envelopes. Yes, leaking a stamp or stealing a letter can give away your identity. And sweat? That's everywhere. It's on clothes, weapons, door handles, or even inside of gloves. Some people think wearing gloves will keep them safe from leaving evidence. But guess what? Sweat seeps from the fabric, and forensic experts can still extract DNA from it. So yeah, saliva and sweat, they are silent witnesses. You might not see them, but trust me, they never lie. And then the last type of evidence are shoe print. Now shoe prints are not something we think about when it comes to crime scenes. So you might be wondering, how can shoes help solve a crime? Well, footwear impressions can tell a lot more than you think. Imagine a muddy footprint left at a crime scene. That single print can reveal the brand, size, and even the wear pattern of the shoe, which can help investigators narrow down suspects. But it's not always just about finding a match in a suspect's closet. Footwear evidence can also tell a story. For example, if a series of footprints change in depth, it might suggest someone is running or carrying something heavy. Also, if there are drag marks, maybe they are injured or moving a body. So here's a fun fact. In some cases, investigators have even identified a suspect just by their unique walking style. Yep, everyone has a slightly different gait, and forensic experts can analyze that too. Alright, so now we know how crucial trace evidence is. But the question is, how do forensic experts actually collect these tiny but powerful clues without losing or contaminating them? Let me break it down for you. Well, first things first, not all trace evidence is collected the same way. The method used depends on what kind of evidence we are dealing with and where it is found. Some materials are delicate and can easily be lost, while others are embedded in surfaces and need careful extraction. So the basic rules of collection are work from the most fragile to the least fragile. The evidence that can be easily lost, like gunshot residue or hair, is collected first. Then use the right tools. No bare hands. Investigators use tweezers, brushes, tapes, and even vacuums to pick up evidence without contaminating them. The last but most important is avoid contamination. Every forensic expert wear gloves, masks, and even clean clothing to ensure that they don't accidentally add their own DNA or mix up the samples. So now let's talk about some of the methods of collection. First is picking. Using tweezers or forceps, forensic investigators carefully pick up individual hairs, fibers, or paint chips. This method is used when the evidence is clearly visible and easy to grab. The next is lifting. For tiny particles like dust, fibers, or even gunshot residue, an adhesive tape is pressed onto the surface and then sealed in a special container. The next one is scraping. If the trace evidence is stuck on a surface, like for example dried blood on a shoe, a clean spatula is used to carefully scrape it off onto a collection sheet. The next is vacuum sweeping. For larger areas like carpets or car seats, a vacuum with a special filter collects particles which are then sent to the lab for analysis. And then the fifth type is combing. Hair samples from a suspect or victim are collected using a clean comb or brush to catch any trace evidence hidden in the strand. Then the sixth type is clipping. Nail clippings are collected to recover trace evidence trapped under the fingernails. A clean pair of scissors or nail clippers is used, and the sample is carefully stored in a sterile packet. Then the last type is swabbing. For biological samples like saliva or sweat, forensic experts use sterile swabs dipped in distilled water to collect the sample. Now once collected, every piece of evidence is properly sealed, labeled, and documented to avoid contamination or mix-ups. Because in forensic science, one mistake can mean losing a crucial clue forever. So next time you see a crime scene investigation in a movie, you will know exactly why they are being so careful, because every tiny trace tells a story. Alright, collecting trace evidence is just the first step, but what happens next? Well, if evidence is not properly preserved or packaged, it can be contaminated, damaged, or even lost, making it useless in the court. So forensic experts follow strict procedures to keep every tiny trace safe and intact. And to preserve the evidences, there are a set of rules and regulations that are need to be followed. The first step is photograph everything. Before touching anything, investigators take a clear, detailed photographs of the evidence exactly as they are found it. This ensures there is a visual record in case anything changes or gets lost during collection. And the next step is sealing and packaging. Every piece of evidence is sealed properly to prevent tampering, contamination, and degradation. The type of packaging depends on the nature of the evidence. So, what about the small, loose trace evidences like hair or fiber? Well, they are stored in clean paper packets or petri dishes, then placed in a paper bag. And for large items like clothing or bedding, they are packaged separately in clean, unused packaging to avoid cross-contamination. And lastly, what about the wet items? Well, they are dried in a controlled environment with no heat or direct sunlight to prevent mold, and any fallen traces are also collected. Step 3 is transporting the evidence. If an item can be transported, for example, a blood-stained shirt, then it is documented, carefully packed, and sent to the lab for further testing. If the carrier object is too large to move, like a carpet with bloodstains, forensic experts collect the trace materials directly at the scene using proper methods. So every piece of evidence is clearly labeled, documented, and handled with extreme care, because even the smallest mistake can compromise an entire investigation. That's why forensic teams take preservation very seriously, because every trace holds the truth. Now that we have collected and preserved our evidence, it's time for the real detective work. Analysis. Let us start with hair and fibers, two of the most common yet powerful forms of trace evidence. First, we'll discuss hair, and then I will move forward to fibers. So hairs can link a suspect, victim, or crime scene together. But how do forensic experts analyze it? Well, microscopy is the first step. Under a microscope, hair reveals details like color, texture, and medulla patterns, kind of like a fingerprint for hair. And then DNA analysis. If the root is present, it can help identify exactly who the hair belongs to. This is super useful in violent crimes where hair might be forcefully pulled out. Now, let's talk about fibers, like the ones found in clothes, carpets, or upholstery. Even a single fiber can help place a suspect at a crime scene. Microscopic examination helps determine if the fiber is natural, like cotton or wool, or synthetic like polyester or nylon. And then spectroscopy like FTIR, UV-Vis, or Raman helps identify the chemical composition matching fibers to specific manufacturers or products. And then lastly, burn test or chemical test can further confirm the fiber types and their origins. So by analyzing hair and fibers, forensic experts can connect the dots, proving who was here and when. And that's just the beginning. Let's move on to the next type of trace evidence. Alright, now let's move on to glass fragments and paint chips. Two types of trace evidence that can reveal crucial details in an investigation. So the broken glasses that are found at a crime scene are not just a mess. They are important clues. Whether it is from a car accident, burglary, or shooting, forensic experts analyze glass to figure out where it came from and how it broke. So how do the forensic experts analyze the glass fragments? Well, first, microscopic examination helps determine the type of glass. Is it window glass, bottle glass, or automotive glass? Then the next type of examination is the refractive index testing. It basically tells us how light bends through the glass that can help match a tiny glass fragment to a specific source. And the final examination can be fracture patterns, which can tell us how the glass broke. Was it a gunshot, a blunt force, or heat? This can help reconstruct the crime scene events. And then paint analysis. To analyze paint evidence, the forensic experts use microscopy, which helps determine the color, the number of layers, and the composition of the paint. And they also use spectroscopy like FTIR, Raman, and UVVs that identifies the chemical makeup, which can match paint to a specific car model or manufacturer. And lastly, chromatography. Chromatography can even analyze the binder and pigment components, helping link a suspect's car and tool to the crime. Now let's dig into soil and minerals. Yes, even dirt can be a powerful forensic tool. Soil is not just mud and dust. It is unique depending on where it came from. A tiny speck of soil on a suspect's shoe can place them at a crime scene, even if they deny ever being there. So how is soil analyzed? Microscopic analysis. Soil samples are examined under a microscope to check for grains, minerals, and tiny organic materials that make each sample unique. Chemical composition testing. Techniques like X-ray diffraction and elemental analysis determine the exact minerals and elements present, which can match soil to a specific location. Color and texture comparison. Forensic experts compare soil texture, moisture, and color to find similarities between crime scene soil and suspect samples. And the last form of analysis is biological content. Sometimes pollen, plant matter, or even microbes in the soil can link it to a specific region or environment. Lastly, let's talk about biological fluids. Things like blood, saliva, sweat, and other body fluids that can be crucial in forensic investigations. These fluids don't just carry DNA, they hold a story about what happened at a crime scene. So how are they analyzed? First, for blood, we have presumptive tests. Quick field tests are used to detect the presence of blood, semen, or saliva. For example, the Kessel-Meyer test turns pink when blood is present. And after presumptive tests, the forensic experts perform confirmatory tests. They go a step further to confirm the exact fluid type using specialized chemicals and techniques. And also DNA analysis. Once a sample is confirmed, forensic experts extract DNA to match it to a suspect or victim. And lastly, spectroscopy and chemical testing. It helps identify components in saliva or sweat, linking them to a specific person or activity. Now, while trace evidence is incredibly powerful, it is not always smooth sailing. There are some real challenges that forensic experts face when analyzing these tiny clues. Let me break it down for you. First is the contamination risk. One of the biggest issues is contamination. Since trace evidence is often microscopic, even a tiny mistake like sneezing near a sample or touching it without gloves can completely compromise the results. That is why strict protocols are followed to prevent cross-contamination. And the second type of challenge is sample degradation. Time is the enemy. Many trace materials, especially biological fluids or fibers, can degrade over time due to the environmental exposure. Sunlight, moisture, and even bacteria can destroy crucial evidence before it reaches the lab. And the third type is interpretation and legal admissibility. Even if we successfully collect and analyze the evidence, the real test is in the courtroom. The defense might argue that the evidence is unreliable or that the transfer was accidental. That is why forensic scientists must ensure their findings are accurate, well documented, and scientifically sound. And the last type is trace amounts and detection limitations. Sometimes the evidence is too small to analyze properly. Advanced techniques like SEM, that is scanning electron microscopy, and mass spectroscopy help. But if the sample is too degraded or minuscule, it might not provide conclusive results. So while trace evidence is a game changer in forensic science, it comes with its own set of hurdles, and overcoming them requires precision, technology, and expertise. And that brings us to the end of this video. We have seen how the teeniest fragments like hair, fibers, glass, or even gunshot residue can tell a compelling story and help crack cases wide open. From Locard's exchange principle to modern forensic techniques, it is clear that even the smallest trace can make a huge impact in solving crimes. But remember, forensic science is not just about the technology. It is about the precision, patience, and the pursuit of truth. Every piece of evidence has a story to tell, and forensic experts are the storytellers who bring justice to light. So these are the references where I've taken my content from. Feel free to check them out. If you enjoyed this video and learned something new, don't forget to like, share, and subscribe to Case 23. And if you have any questions, thoughts you'd like me to cover next, drop them down in the comments below. So until next time, stay curious, stay forensic. Bye bye.